Hello and welcome to the DCG Development Update. We are here to share what we've been working on over the past 2 weeks. If you have any questions during the update, please use a Q or a question prefix, and we'll be answering those questions at the end, so please stick around for the Q&A session. Without further ado, let's jump in, and let me find the sharing button. Okay. Sam?
Yes. Okay. So what have we been really focused on for the last 2 weeks? So it's really been the address system in platform and Dash Pay for Rust Dash Core. Actually, sorry, it's actually not been Dash Pay. It's the Dash SPV in Rust Dash Core, and they've been doing amazing work there, and we've been doing amazing work for the address system as well. So we're going to talk all about this, and hopefully people will be as excited as me at the end. So let us go in to the first slide, which is probably platform stuff.
Yeah. Hi, so that's just a summary of what I worked on in the last 2 weeks. First of all, mainly I did some work on platform, tender dash, no actual progress in the sprint. In terms of platform, we finalized backporting of some changes from previous 2.1.3 release into the 2.2. It was a small, let's say, technical task, just to have the same code base and all the fixes. And there was a big topic that when you reset a master node or you deploy a new master node, sometimes it fails to sync properly. So the error is that uphash mismatch is displayed in logs. Fortunately, this should be fixed, and we are not aware of any problems with this anymore. If anyone has issues with rsync, he should just use -d version 23.02. It needs to be a manual update, and it should fix itself. If this version doesn't work, please just report some bugs so that we can investigate further. But basically, hopefully, this error will not happen anymore. And in terms of work that is more in progress, there is a bug fix in RSDAPI to have better error messages when something goes wrong when you do a state transition. It's in a review, and yeah, it was basically waiting for its time to sprint. And second one, which I marked as on hold, is quite a big topic of event subscriptions. So we switched to something else right now, but it's basically ready for review. But we just don't want to spend time on this right now because it's quite big. And there's a side fix from the resync topic that we work on, where uphash is not always verified in finalized block. And in some edge case, it can cause the node to go one block forward and then fade. It's better to fade one block earlier because it can be recovered. If it fails one block later, then it's not recoverable, and we need to reset the node to recover. So it's just a small fix. It needs some testing to see if it's not breaking mainnet, for example. So I need to replay the whole mainnet on that, and then it should be ready for review. And another side product of my uphash mismatch investigation is a small tool where we can take logs from drive and feed them into a local drive instance. and it will just execute the same transactions locally. It's really, really useful for debugging, and that's how we were able to find find the core issue of the resync problem. And the biggest task we are working on, and I have spent quite much time on this, is the platform address support in SDK. It's basically part of the big task that Sam is working on, and I'm sure he will report on that in more details. Yeah, I think that's pretty much it.
Yep, and the last one is actually mine. I just added it here because I
Yeah.
didn't know where else to put it. No, go back. So platform state refactoring. So there's a structure called platform state. I know it's confusing, but we have one structure. It's called platform state, and it has specific things inside. That thing, it was needlessly complicated because in our versioning system, when I did the versioning, I did it a little bit, not knowing how good it was going to be, right? So I versioned almost everything. Turns out not everything needs to be versioned. About 80% of stuff needs to be versioned, and the rest 20, uh, because it's only in memory. Instead, you don't need to version. There's some stuff that you just don't need to version, and platform state was one of those things. So basically, there is a saving of the platform state, which is called platform state for saving, that does need to be versioned, but the platform state itself doesn't. Sorry, I'm over talking about this. Just refactored it. It was a few hours of work and it's been merged in. So I just wanted to add that in. Okay, let's go on. I'm going to talk about the JS SDK now. This is work done by Ivan. So he's been working on the JS SDK to get it up like a lot better for the next version. A lot of autocomplete stuff, and so this is the work that he's been on. He's also Ivan's also been reviewed the entire address system, right, and helped me with that. So he hasn't only been on the JS SDK, but he's also, I mean, one of our objectives is to get that better for the next version and constantly improve it, right? The first one was the first version, and based off of feedback, you create a second version, and that's what we're doing. Okay, let's go on. Yeah, so Paul, this is yours. I would wait for the demo until we're done talking about the address system.
Yeah, okay. Yeah, thank you. I've been working on Dash Evo tool and SPV this sprint, mostly SPV actually. Lots of stuff to fix in there, like a lot of bugs really. And so I've been kind of like being support for Kevin, who um, has been doing an amazing job and setting up a nice system for us to sift through everything and get it working well. Yeah, so I've done a lot of reviews for him, and some more minor PRs, but the other things that I've done in Rust-Core was I added the platform addresses to Rust-Core. So Sam wrote like two new diffs, diff 17 and 18. And I did, yeah, basically the stuff in Rust-Core that needs to be done, like adding platform address account types and derivation paths, minor stuff in SPV. And then in Dash Evo tool, so I had started last sprint on basically implementing full HD wallets in Dash Evo tool so that when we do SPV sync, we can keep track of accounts and stuff and have those balances populated and everything. And that's all working very nicely. really yeah, I mean, SPV, the happy path works, so it's good for me for building stuff like that, but there's the non-happy path stuff has some issues. Yeah, and then I implemented platform addresses and basically everything to go with that, which I'll do a demo later. And I did some testing as well, and yeah, so everything is working flawlessly. So yeah, I mean, at this point, everything is working really well. So
It's
it's
really
good.
nice to hear. We've been,
Yeah.
it's been, I've been in cave mode. So like, 16-hour days to get this thing out. One thing that I wanted to talk about really quickly is DIP 17 and DIP 18. So DIP 17 is how wallets deal with platform addresses. So basically, it's the equivalent of BIP 44, but for platform addresses. Basically, the derivation path that we use and how it's done. Like, yeah, what these different parts of the derivation path mean. DIP 18 is the address format. Now, I wrote DIP 18 kind of as a feeler, where we basically were going to have addresses a little bit like we have them in core, starting with a D instead of starting with an X. Now, I got some feedback on that, and a lot of people in the community, well, not, I mean, the few people that I asked, preferred that we used BEC 32 addresses the BEC 32 address format for the platform addresses. So we're going to kind of switch to that. Today, the demo and the system is currently using the different address format, but again, it's front end only, right? So it's not the back end, like all the platform code doesn't care about what it looks like, the address. It's more of a UI thing and something that needs to be changed in Rust Dash Core. So that we're going to switch it because just people have said that they prefer the other one. And I also think it looks a little bit more modern and it says Dash in the front. We're probably not going to call it Dash for Dash platform addresses because if we ever did BEC 32 in core, we'd also have Dash there. So we're going to make it very obvious which chain it's on, etc. And it's going to be, I think, will be very nice. Okay, let's move forward. And yeah, so last time or 2 weeks ago, the validation weren't done for the 6-state transitions. Now they are. And also tests were written, and the tests took a lot of time to write so many tests. We did a different approach this time. Basically, I took an AI and I told it what's everything that can go wrong, and then reviewed everything that could go wrong. And for some state transitions, this was like 70 tests, right? Like very, very like edge cases again and again. And what's so cool about this is that it found a lot of things that I then fixed. So the system is it comes out of the gate pretty hardened. And then I, tried to attack the system myself. It seems pretty hard. We're gonna have to do more testing, right? Like manual testing, but just based off the tests alone, like how many we've found. And AI is really good at this. AI is really good at going through a lot of code and trying to highlight flaws. It highlights a lot of things that just don't exist. And then it hallucinates problems, and then you have to explain why there isn't a problem. And then it's like, you're absolutely right. I'm sure everybody who's dealt with AI, or at least Claude, knows you're absolutely right. But yeah, so I really wanted to make sure that this goes extremely smoothly when we release. So we wrote a lot of tests. There is also something else that I didn't talk that I haven't written anywhere, but the address system is using the the sum tree system, right? So if there's ever a mismatch of amounts of credits on the system, the platform chain will stall without producing a block. So basically, the system ensures that you can never create money out of nowhere by definition, right? So it's not even done at the, it's like a two-factor auth type system where it's just not possible. Or you'd have to break both mechanisms at the same time, and I don't think that's possible. Okay, let's go on to the other estate transitions. So, we had identity transfer to address. Yeah, so there's also identity create from addresses, identity top up from addresses. It's basically all directions that you can go in. And then we have these last two ones that hadn't even been started. They're almost done now. The addresses fund from acid lock is done, and then the address is withdrawal. I thought it was done. So Yvonne reviewed the PR over the last 3 days. I think he worked Sunday, Monday, and like full day today. And so the PR, this whole system, right, is 65,000 lines long now. It's a big update. And he did find an issue. The only issue he found was in addresses withdrawal, and there was some validation that allowed for withdrawals that would later fail, basically. So it could cause there's some types of failures that need to be earlier than others, and it can create some problems. So yeah, it's great that he found those. So we're gonna fix those, and then we'll have these all done. What other tests do we have? So actually, before we go on, we do have something called strategy tests. So the previous tests happen when, like, for every state transition, we verify everything that can go wrong when we run that one state transition, right? The strategy tests basically run thousands of these transactions back to back of simulate a real system with, thousands of transactions of various types, all hitting the blocks, in random orders and seeing everything that couldn't go wrong. So we're working currently on the strategy tests, and that's probably going to be done, later this week. As Lukasz said, he was working on the SDK part, so he's very advanced there. I feel like, that's mostly just waiting for the strategy test to finish testing there. We also have the JavaScript SDK work that Ivan will take on later this week. It's not a blocker for release though, because, well, it takes like 10 days for us to activate. So the SDK isn't really a blocker for the JavaScript SDK isn't a blocker for, the release. It just means that we need to release that within 10 days of releasing the next version. What else? Okay, yeah. So this is something also that I worked on quite heavily, like the anonymity of address queries. So I touched about on this 2 weeks ago, and I basically talked about progressive Grove DB querying. And yeah, so it works by, we start a query at the top of the address tree, and we see the structure of the tree. Now, the seeing of the structure of the tree wasn't good enough in the current system, right? So there was a PR that I started in May because I kind of thought that we'd eventually run into this problem. And I went back to that PR. It had tons of issues, and I fixed them. And I'll kind of talk about that a little bit afterwards. So the idea is we progressively get tree chunks down the tree from different Evo nodes. You don't want to hit the same Evo node too much because, you can hit the same Evo node for the root. It depends. You have to take chunks from, if you take the same Evo node, you need to do chunks that are one after the other. There's a lot of like stuff that you do to completely keep your anonymity. And then we ignore groups of addresses we aren't interested, and then we basically get subtree paths. So let's kind of talk about in Grove DB how this will look. So next slide.
Maybe we have a lag. I already.
Oh, okay. Yeah, no, it's good. So yeah, the thing that we needed to introduce were state counted trees. So we have count trees, we have sum trees, we have count sum trees. The count trees prove the they're very good for things like for averages where you want to know the average of a set of items, but you don't care about the actual structure of the tree. Because if you were to do it in the actual structure of the tree, it becomes a little bit more expensive. The state counted nodes basically include the count inside the tree structure itself, inside the node hash. By doing so, the count then becomes a provable item that you can return to leg clients. Why would you care about individual node counts? Well, based off of individual node counts, you can actually know the depth of the full tree. By knowing the depth of the full tree, you can then devise a strategy to preserve anonymity to query the full tree based off of subnode count. And that's basically what we do. And what we're going to be doing for address anonymity. So basically, like clients will be able to sync, like, sync their full balances with full anonymity in, well, so let's imagine you have 60 addresses to sync. Well, generally so let's imagine you have 60 addresses to sync. It would take you probably about 10 seconds to do a full sync, right? So compare that to how long it takes core to sync. We're talking like, a million times faster, right? And at the same time, you have the nodes don't learn anything about you. So it's extremely fast at syncing. So that's how we're going to preserve anonymity. For the first release of 3.0, we're going to include the state counted trees. We're not going to include the actual query yet, and maybe we will. It's probably going to take a week longer, so we're probably going to do a fast follower with that. Now, remember, this won't be actually very useful until we have mobile clients that support it, right? So it doesn't. It's better that we get the big feature out first, and then we can build upon it. But we do need to have state counted trees so we can build this feature at a future time, because we won't be able to change the tree structure after we release. I mean, we can do anything, right? But it's a complex migration. We don't want to do complex migrations. It just adds more work. So this is a lot more efficient. Oh, yes. Oops. You gave it away, Balash. I wanted to do the demo first, but whatever.
Okay,
Yeah,
sorry.
so it's okay. So with all of this, we're gonna actually, well, I mean, it's done now. With all of this, we're going to rename 2.2 into version 3. Our versioning strategy is basically the following. When we get a big feature out, like very big feature, we're going to be upping the major version. In this case, there are 6 new state transitions. There's going to be, a new Grove DB version, a new breaking Grove DB version, actually. There's actually quite a lot of fixes in both speed and stability. And yeah, it's just becoming a lot of work. And also, like, when we talk back and we say, oh, when did platform introduce addresses, right? Well, we don't want to say, oh, it was version 2.2. It's version 3, tokens version 2. Obviously, like when we do upgrades and we do new things that are like, okay, we're going to introduce, you know, some advanced feature for token or some extra thing for addresses, we'll do a minor, right? But for something as big as this address system, we're going to version 3. Yeah, so I think it's time for a demo, Paul. What do you think?
Sure. Okay. So I'll do a quick demo to show the functionalities in Dash Evo tool. Here. Okay, so we're looking at the new wallet screen. Maybe not finalized, but I mean, I threw something together quickly so we can test everything. We may try to clean it up. But yeah, let's see. New functionalities here. I think I showed already before. We have like all the accounts and stuff. We're basically mirroring the iOS example app that Sam and I think Pasta have been working with a bit. But let's see. So there's this button here, receive platform credits. So we have like platform account now, basically. And if you scroll down, these are platform addresses. I'm on a local network, so it's a little lowercase d. I think mainnet is uppercase D.
For now.
Yeah. And I have some addresses with small dash balances here. So I can receive platform credits and I get a QR code. I can generate a new address, copy address.
Uh,
Let's
you might need to go a little slower because it's like it's jumping.
Oh, okay.
No, it's
I'll
good now.
talk slower.
No, not you. The image, the video is like jumping a little bit. So when you go quickly, it just jumps some frames, and we don't know what's going on.
Oh, okay. Okay. Yeah, so I'm gonna click new address and I'll copy address. And so I'll just show like one of the state transitions you can do now is transfer from identity to a platform address. So I'll go to my identity here, actions, transfer, and let's send half of my dash balance, 0.1. So now down here you have an option to send to platform address, and I'll paste in here. I'll probably make a selector here, and so you can select loaded addresses instead of having to paste. Transfer, confirm. I'm using a local network, so it's super fast. Yeah,
You
let's go
just have
back
to
to
say it's
identities.
this fast in reality.
Yeah, I mean it is fast, definitely super fast in reality too. But let's see. And now I'll refresh. And I have a new address with the balance here. And I can show you the Docker logs if you want to see the block actually come through and stuff. But yeah, that was kind of my experience with all of the 6 new state transitions that Sam added. Like there was 1 or 2 small bugs that uh, we fixed really quickly, but I was pleasantly surprised that like everything worked really well. right off the bat. So, yeah, kudos to you, Sam and Claude. And
No, Claude is
also
not doing
Lukash.
well. Claude wrote a lot of the, well, it helped out with the tests, but the actual code for this was mostly me, right? Like I wrote like 20,000 lines. It was like back before AI. I mean, AI drives me insane to write like production code. It's just you end up spending more time than it's worth.
Yeah.
Um, yeah, so actually here we can see like, these addresses are paid to public key hash, right? So we
Mhm.
support two types of addresses in the first version. Um, pay to public key hash and script hash, but in the script hash we only support for the first version multi-sig. So you can do multi-sig payments as well. Um, just as you would do multi-sig like, in core. Not exactly the same, but quite similar, like N of M. So you could say like 3 out of 7 people need to sign. And if you have 3 out of 7 signatures, then you're good to go. Um, yes. What else? Do you have a like, oh, you just do a transfer from address to address?
Yeah.
Oh, yeah, that was pretty cool. Did and you did well, yeah. So what about like address platform address to core address? Did you implement that one yet?
Platform address to core address. Isn't that's withdraw to core? Yeah,
Yeah.
I did. Um, let's see, platform address. Let's do this one. DLD send 0.05 to core address. Let's see, receive, copy. Sorry, I'm going fast. And paste this core address and withdraw
So
YQX.
this will actually take some time, right? Because you need a withdrawal takes 4 blocks to complete.
Yeah.
So
So yeah,
you can just if you can create 4 state transitions, we can cycle through 4 blocks really quickly.
there. It happened already because it's on a
But
local network.
oh, it happened already?
Yeah, it's a local network, so it's like 10 seconds.
Oh, okay, cool.
Yeah.
On main, yeah, a withdrawal to core takes about 45 seconds. Or no, it takes 3 to 4 blocks, right? So that's just part of our security model there. Well, it's part of our system. It's some of it is security, some of it is just system. Um, Yeah, so that's basically our address system and platform. It's not a UTXO system. So UTXO basically takes transaction outputs as the inputs. In our case, we're using addresses as the inputs with a nonce, right? There are advantages and disadvantages, but for a state system like we've built, it just seemed better to use address with nonce. Um, it just seemed better because then you can look up your address balances. I mean, it's just faster and easier that to do it like this. Also, it makes transactions like if you don't care about revealing the public key of your address, right? So let's say 90, like a good chunk of Bitcoin and Dash actually have like public keys because people reuse addresses. So if you've ever reused an address, your public key is valid, is public. Now, what is a problem with having a public a public key? uh, when quantum computers come out, these addresses will be broken, right? Because you'll have revealed the public key, and if the quantum computer can break a discrete log, and can break this problem, which it probably will one day be able to do, then revealing public keys will be a problem. Do I think that there's a chance that this happens in the next 6 years, 5 years? No. I mean, less than 1%. So like quantum computers are way out. Even on an it's a little bit like fusion, right? In the 70s and 80s, fusion was 10 years away, and it's going to stay 10 years away for some foreseeable future. It's not as hard as fusion, I would say, but it's not. It's a different set of problem. It might even be harder to get it that much. Like be able to process that many qubits without decoherence. But yeah. So moving on, if you don't use a change address, you save on fees. You can use a change address and fully pay with your address. So like, if you want to be completely quantum secure, platform addresses allow you to do it. If you don't want to be platform secure, like, Bitcoin allows you not to be, right? By having your change address be your same address, you don't have to be, and your fees are cheaper. So there you go. We don't, well, I mean, we just make things cheaper. Keeps the same security model, but cheaper. What else do we have? Oh, also, in the state, when you're sending to an address, each output is a node that costs about 100 and about 200 bytes in the system, right? That's just the cost of an address in the system. So if you're sending to one address, your state cost in fee is probably going to be about 200 bytes. A Bitcoin transaction costs about, or Dash transaction is very comparable, but it doesn't have, the lookup features and the decentralized features, and that's where our 200 bytes come from. Okay, cool. Let's move on. Rust Dash Core. So, what is all this for people not knowing? Rust Dash Core, it's mostly the work here is mostly Dash SPV. So we now have a new team comprised of Dustin Face and Borka. Dustin Face is Kevin, and somebody else that we hired last week, who is turning out great. Actually, both of them are just doing they're doing a really, really good job cleaning all of this up, this vibe coded stuff. I'm wondering if Pasta is going to say anything. I guess not, but it's really like, I'm looking at the PRs they're doing. They're just killing it right now. Now, did I think it was going to be? Did I think that there was going to be so much? I didn't actually think that it was. I didn't know that so much needed to be cleaned up, but yeah, they're just going through and cleaning everything up, and making the SPV sync work really well without without deadlocks, like destroying all the edge cases. Once that library is done, we're going to be able to turn around and fix things on iOS, and by using this library. So a lot of progress going on here, and I was on it. I am so happy that I'm no longer on it, and that somebody is doing this painful thing for me. So yeah. Kudos to Kevin and Borka. They are in a different time zone, so they will never be able to really join this review, just because like right now it's they're sleeping. It's the middle of the night for them, but I'll keep on giving updates on this. Okay, I think we have one thing today that we have to let you guys know is we are not going to give a mobile update because Brian had a last minute emergency. So he's not here, and I haven't been briefed on it. So we're just gonna skip it for this week. We really want to apologize for that. Emergencies happen. So
We will keep you updated in
yeah,
Discord.
if you have any questions in Discord, we'll answer there. Probably Brian will answer tomorrow if anybody asks anything. Okay. Let's move on to
14.
Awesome. Cool. Thanks. So, starting out with V23 adoption, this is going to be the red section and the orange section here that we're looking at as V23. So we're looking at around 43% adoption right now. So, that is the, I guess, largest, chunk. 22.1.3 is right around 42, and our 23.x is right around 30 or 43. So just a hair more than 22.1.3 right now. And hopefully we'll get some more adoption in the near future and get everyone upgraded to 23 soon. But overall, adoption looks fine. We're not in a huge rush per se, but it would be nice to see this tick up a little bit more in the next little bit. So next slide here. So 23.0.2 did get released recently. It resolved an issue in some historical EvoDB data that got corrupted during migration due to v23 on some nodes. And so that got repaired via like an automatic migration when you upgrade to 23.02. So we would like, everyone to upgrade to 23.02. Even if they're already on 23, upgrading to 23.02 is recommended. Extended addresses is still being worked on and progress is made. Nothing super crazy to report there. Hopefully I'll have something more substance this next week on extended addresses. Kitty Whiskers was primarily focusing on some other tasks this last week and didn't spend a ton of time on extended addresses. There was a feature kind of vaguely requested by a couple of community members, reworking how we do basically our wallet backups in core, so that if something on disk gets corrupted or something happens, that you have some older backups. And there's a PR open right now that I opened and Eugene has helped improve that makes this more of an exponential system instead of just keeping the last 10. So hopefully that will be able to get merged in the near future. Past 2 weeks, we did finalize pretty much all of the instance end improvements that I had been working on. There are maybe a couple more things that would be valuable and hopeful, but for the most part, most of the changes related to instance end throughput and latency have been implemented, and I'm seeing quite solid improvements on testnet, and those will be included in 23.1, which hopefully we'll be able to release maybe sometime this month, if not early Q1. We should have 23.1. In the release process for 23.02, we did identify a non-determinism issue in our Guix builds, and so that slightly delayed 23.02, but we were able to solve it within a couple of days and then release. And that's why it was 23.02, because 23.01 had some non-determinism issues that we had to resolve. We implemented a new modification where we will now trickle out. Currently, the logic is that masternodes immediately send transactions to all other peers. This is great in some sense. It makes masternodes a really fast backbone for transaction propagation and getting everything sent out through the network. But it adds some extra overhead, and it potentially could leak some information. And so to reduce to reduce CPU needs, and B, reduce some of that potential information that could be kind of gathered, master nodes will now kind of trickle out transactions to non-master nodes. And so master node to master node will still be very quick and immediate, but master nodes to non-master nodes will have a delay between a half second and a second to send out transactions. But this helps us kind of bundle some stuff together on the networking side, and won't affect kind of observed performance or anything, but and should make some complicated, very like high level network analysis much more difficult. So yeah, as well, I looked at and investigated being able to run Dash Core using Wayland natively and not using a X11 compatibility layer if you're running on a Wayland desktop. I think there are a couple of there's a potential for right now, if you're running on a Wayland desktop without some compatibility layer, you won't be able to run Dash Core and stuff will just crash. I think this was an issue reported to me recently by Latte. At least I think this is the issue that he saw. He was running in an Arch VM, I believe. And so I'm not positive if this is the same issue. If anyone has a desire to run on Wayland natively and not use an X11 compatibility layer, or oppositely, if they have some reason that we really should not support running in native Wayland, go ahead and let me know. But I implemented some changes that would allow us to run natively on a Wayland desktop without any compatibility layer. And this is for Linux desktop specifically. So yeah, we can move on to the next slide here, and we can see the backport status. We added V30 to the sheet recently, and so that dragged down our total percentages a little bit, but V25, 26, 27 are all coming along and making solid progress. So yeah. All right, next slide here, you can see the list of merged PRs. And so quite a few things were done. There are various CI improvements, there are various fixes, and a number of backports, as well as you can see a number of PRs related to the LLMQ signing improvements and latency. So yeah, that can be a wrap, and we can move on to questions.
Thank you very much. So I see one question, which is when will the app will be finished and the system will work and will be finished and the dashboard will activate? I'm not sure what it means.
I've probably, I don't know what he's talking about. I think he's probably talking about there's a card that like Zebek, I think, card that's recently happened, but it's not from us. So
All right.
yeah.
Then thank you very much. Thank you for the questions. Thanks for being here, and see you in 2 weeks.